Hello everyone, I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that turn out the products we see around us every day. There's a whole new world of things waiting for us to discover here on How It's Made. So just what is incense? It's an ancient recipe that hasn't changed since the time of the Egyptians or the Mayas. You simply mix some juniper or pine resin with fragrant spices, flowers, and vegetable oils. You take this mixture, cover a bamboo stick, and light it. And enjoy. On today's show, trucks, adhesive bandages, computer circuit boards, and liquors. Eight, 10, 18 wheels, trucks transport most of what we use and consume daily. You've got to respect them. They're the undisputed giants of the road. Fabricating these massive trucks requires many highly complex steps, since the parts are usually heavy and tricky to handle. Assembly begins by fabrication of the bearing frame, the main part on which will rest the truck's cab, the motor, and the transmission. They begin by assembling these tempered steel stringers, beams varying in length between 7.5 and 13 meters. The chassis is made as a huge mechano set. The stringers are solidly attached together with nuts and bolts and tightened with powerful pneumatic tools. Once assembled, the main chassis is transported to another stage of construction. Now they're going to install the mechanical parts. They start with the differential, the axle, and the spring sleeves. The brake mounts are then put in place. The plates installed in the mounts allow the truck to brake. They install the wheel hub onto which the wheels will be attached. Then the transmission shaft is inserted, which will power the driving wheels. They then finish the rear wheel assembly by mounting the heavy brake drum made of cast iron. To facilitate the mounting, everything is assembled upside down. With an overhead crane capable of lifting a 12,000 kilo load, they then turn the part right side up. Next up, the motor propulsion elements. The transmission is bolted to the motor, seen here in yellow. The motor propelling elements comprise the clutch and the transmission installed at the front end of the truck chassis. A truck has between 6 and 10 wheels, 22 inches in diameter. The tire and wheel together weighs about 55 kilos. Because of this heavy weight, the wheels are installed with the help of this powerful tool. This bolt fastener allows tightening of all the wheel nuts at the same time. The mechanical portion is ended, and they now proceed with the cab assembly. This begins with painting. The cab is moved toward the front to facilitate the installation of various components. This worker attaches the support for the horn to the roof of the truck cab. Now for the cab's interior. They begin by installing the dashboard, which weighs about 35 kilos. Following this, they attach all the wires, the turn indicators, the speedometer, and the pedals. The seats are then installed, and the cab work is now all completed. It's bolted onto the chassis. Now for the motor's hood. They finish off with the lights, the exhaust pipe, and the mud guards. The truck is now almost ready to hit the road. They start it up and verify that everything's operating properly, and it's now ready for delivery to the customer. It requires 95 to 100 hours of work to assemble a truck like this. In spite of their 5,000 kilo weight, these trucks can move along at a top speed of 120 kilometers per hour, and they can carry a load of some 28 tons. I've cut my fingers and I've got a couple of options. Bulky gauze binding, flexible adhesive bandage. Bulky binding, flexible bandage. I take the flexible adhesive bandage. Adhesive bandages are made of various materials, among which is the main support called ETS, a fabric which is elastic in only one direction. It's a fabric which will become the adhesive portion of the bandage. This 1,800 meter roll of fabric can make 1.8 million small bandages or 300,000 large bandages. A thin coating of glue is applied on one surface of the fabric. Then it's heated to 49 degrees centigrade in an oven to puff it up, creating holes in the glue coating. Then the fabric is newly rolled up into 300 meter lengths. Bandages are of different sizes. These blades cut the glued rolls into strips of varying widths. These rolls are taken away and stacked, ready for the next step, application of the little cushioned protective pads. The material used for the pads are shown here as a large roll of fabric, which will have to be cut. Here a machine cuts the fabric pads. These extremely sharp blades have to be sharpened every 6 months. The cushion fabric is separated into narrow strips, which will later be glued to the ETS fabric. The strips of cushion fabric are now ready to be applied to the bandages. This is the machine that fabricates the bandages. The roll of bandage components is unrolled. The machine assembles them, then cuts and individually wraps them. The bandages are wrapped one by one. This machine applies the unprinted white wrapping paper, which protects the bandages. And now they proceed to packaging. Packaging speed depends on the product, varying between 300 and 1,500 bandages a minute. This roller perforates holes which will allow the bandages to be easily separated from one another. Strips of bandages are then placed into boxes. Here we see other small bandages which are made in a different way. The cushion strip is positioned at the center of the ETS fabric strip. The cushioned pad isn't sterile at this stage. They will have to be sterilized right at the end of the fabrication process. Next step, applying 2 plastic paper protectors over the glue-covered ends of the bandage. This done, the bandage is drawn by suction with a robotic arm and placed between 2 wrapping papers. In slow motion, we see the wrapping action better. This machine is much faster than the eye. At full speed, it can wrap 300 bandages a minute. The bandages exit the machine perfectly wrapped. Certain types of bandages have to go through a sequential bandage machine to have aeration holes pierced in them. These holes allow air to circulate and thus help promote healing. These bandages are now ready. Sometimes they print instructions on bandage wrappers. This paper printing machine is used with bandage machines. 2 polymer plates receive ink from a series of rollers in order to reproduce the desired design. The bandages pass through at high speed. Before being packaged, the bandages are finally sterilized 10,000 at a time. Bandages are automatically counted here, placed in a chute and fall into the packaging box. The large roll of ETS fabric seen at the beginning will have allowed them to make nearly 2 million bandages. Each year, this facility produces a staggering 4 billion bandages in 65 different models. Electronic circuits once involved miles of bulky wiring. Today, they're reduced to compact units, like this computer circuit board. If there's a problem, simply pop in a new one and you're back in business. An electronic circuit board is a computer component which can produce spectacularly realistic scenes. Animating this particular three-dimensional graphic took 4 months of work by artists and programmers with the aid of a G400 graphic processor by Matrox. A printed circuit board can be compared to a building composed of fiberglass floors, copper passageways, and stairs that link the floors between them. Cards are assembled with two technologies, surface wiring and wiring through the card. The components are placed into the holes and soldered into place. A stencil is used to apply soldering paste onto the card. This paste will solder the surface components. Here they place the stencil into the printing unit. It is through these holes that the soldering paste will run. The machine spreads the soldering paste, which contains, among other elements, a tin lead alloy. The printing blades go into action. They spread the soldering paste on the stencil. This paste runs through the stencil holes and covers the metallic surfaces of the printed circuit board, which will establish the electric current. Here's the difference between an unprinted card and another printed one. The unprinted card surface is much more shiny. Now they're going to install the surface wiring elements. They are automatically positioned by this rapid placement machine. About 36,000 components are installed per hour, making it about 10 a second. This incredibly sophisticated machine is equipped with a viewing camera which verifies the alignment and dimensions of each part before installation. It unerringly positions the part at the exact spot. Another machine, slightly less precise than the previous one, installs parts where the space between two placement points is less than 0.5 millimeters. It can install 8,000 parts in 60 minutes. The card continues on its way toward the oven, which accomplishes an essential operation. Once the parts are secured, the card goes into a convection oven where the heat will solder the parts to the card. Different circuit connectors through the card are inserted into their respective holes. This operation requires great dexterity and is entirely done by hand. Then the metallic placement points need to be soldered to this card. The soldering of the circuit components through the card is done with a bath of molten tin lead alloy at a temperature of 240 degrees centigrade. Now everything is installed. They have to do an initial electrical test. The card is placed on a bed of electrified pegs. These pegs make contact with the card's connecting points, allowing them to check for short circuits or open circuits in the card. And then a final test, a computer-aided operating test to see if the card is functioning perfectly. company fabricates 200 models of different circuit boards and produces about 4,000 cards each week. Cereal grains, water, fermentation, and distillation. These elements and processes transform into alcoholic beverages of distinction and tradition called spirits or liquor. The principle of distillation was known to ancient Romans who mastered the process. However, we still don't know the precise ingredients they were using. In the Middle Ages, stills produced the first alcohols from wine. The 7th century saw people making ethyl alcohol, and by the 15th century, the process was further refined, leading to the production of today's brandy, bourbon, cognac, and whiskey. Dried corn kernels is the main grain used in making spirits. Every day, 7 truckloads empty out 230 tons of it. This corn will produce the basic ingredient for spirits, such as whiskey, gin, creme de menthe, and amaretto. The kernels are stored in these 24-meter-high silos, which can hold up to 250 tons. This is the distillery control room. They're going to make a recipe that's 95% corn and produces neutral alcohol, to which they will add other grains for color and flavor. We see here the first step, the milling of the grain. Some 8 tons of corn flour and 18,000 liters of water are introduced into this autoclave and cooked with live steam for 90 minutes. Enzymes transform starch into sugar. Then they add the yeast, which converts sugar into alcohol. Fermentation lasts 60 hours at 38 degrees centigrade. The bubbling we see is created by the action of the yeasts. This cone removes the CO2, a natural byproduct of fermentation. Nearly 70 tons of CO2 are drawn off daily. Everything is monitored by computer. Some 24 hours have now passed since the start of fermentation. When this stage is ended, corn oil will have come to the surface and is clearly visible by its reddish color. The fermented mash has a 13% alcohol content. They now move on to the next step, distillation, which condenses the vapors of the mix. It's in this 3-column distillation system at a temperature of 85.5 degrees that the mash ferments and is distilled by live steam to separate the alcohol. All the distillation columns are continually monitored. During distillation, they dry the grains used in the recipe in this rotating drum. The resulting product is called draff, and it will be used to make animal feed. Distillation is now ended. To aromatize certain gins, they add dried lemon skins, some cinnamon, or coriander. Rum and whiskey will be aged in these 350,000 oak barrels. While aging, these spirits will lose about 3% of their alcohol content annually through evaporation. Also, the color gradually darkens. They're now ready to draw out the liquid from the barrels and put it into bottles, but first they have to verify the quality of the spirits. They compare the standard product with the new production. This test is highly important in order to assure the quality of the final product. Bottling begins. Here, 140 750 milliliter bottles of rum and spirits are filled every minute. Clean bottles circulate continually on the conveyor, leading them to the filling machine. Bottles are then filled automatically by this machine. It allows an exact quantity to flow into each bottle. The next step, a capper places caps on the bottles and crimps them onto the necks. Then the sealed and labeled bottles head for the packaging department. This other machine fills 120 bottles with 1.14 liters of Canadian whiskey every minute. In this distillery, some 20 different spirits are produced. With 34,000 tons of corn kernels, they produce 44,750,000 bottles of spirits annually. I hope you enjoyed our show. We wanted to take you behind the scenes of the world of manufacturing. I'm Mark Tewksbury. See you next time on How It's Made.